We have to do 9 example. All right, so make sure we listen to Carter. All right, Margot, help us read the instruction to 1 to 7. Okay, so Margot said determine which option to use and then use it to solve. Okay, let's go. Example 1 says log base 7 of 2x plus 1 equals to log base 7 of 3x minus 5. All right, guys, do we have one log on each side? Yes, so this is option number 1. And no, we don't need to state option number 1. So based on that, it says get log on each side. Yes, we do. Check. Remove it. Number 2, set the inputs equal to each other. Guys, if you have an equation and these are identical, if we remove it, would the equation still be equivalent? Yes. So now we do 2x plus 1 equals 3x minus 5. Is this something we can solve? For sure. Let's solve it. What's next? What should we do next? Move what? 5 and move? Yep. So let's move 2x to the right. At the same time, move the 5 to the left. By the way, does it matter which way you move it? Nope. 6 equal to what? X. We have to check it before we can box it up, because log cannot be what? Negative. All right, here we go. On the left side, 2 times 6 is what? 12 plus 1, positive, negative. That's all we worry about. On the right side, 3 times 6 plus 5, minus 5, positive and negative. That's right, box it up because they're both positive. Okay. All right. Number 2, as you can see here, we do not have one log on each side, so we have to condense it. So number 2 said log base 2 of 6 plus log base 2 of x equals to 3. In log, when you have an addition of 2 logs, how do we condense it? Multiply. Yep, it becomes log base 2 6 times x. Now we don't, yes? We don't know. Okay. All right, we only have one log, y'all, okay, on the left side. We can't drop it. We can't drop the log 2 because it won't be equal. So we are going to rewrite it in what form? Exponential. We should be able to go backward and forward. Your base is what? Base is 2. 2 to the what power? 3 equals 6x. 2 to the third is what? 8. Divided. All right, divide both sides by? So x equals, reduce that. Someone tell me how to reduce that. Divide. Okay, 4 over. All right, check it before we box it. Plug it in. Will it make any of my log negative? No, so box that up. Oh, where did my go? Sorry, it moves on me. Where did it go? All right. Okay. Number 3, let's go. Check it out. Tamer, do we have the same common base log on each side? So can I drop it? Yep, let's drop it. What do we have, Tamer, if we drop the log base 12? What do we have if we drop log base 12?
X plus 5 equals 3x plus 31.
Great. All right, we do need to solve this. So Katie, what do you want x to be? Left side or right side? Left side. So guys, move the negative 3x. At the same time, can I move the 5? By the way, you don't have to go left. You can do whatever side you want. Okay? Cancel, cancel. All right. How many x's left, Katie? 2. Positive and negative. Negative 2x equals, Katie, 31 take away 5 is? All right, Katie, divide both sides by negative 2. X is? All right, let's plug it in, y'all. Negative 13 plus 5. What happens? Uh-oh. Whoopsie. Can I have it? No. So we can't have an answer here. So no what? No solution. All right, y'all. ln represents what? Log base e, natural log, okay? So instead of just now wood, it's an organic piece of wood, okay? All right, same? Do you have one natural log on each side?
Yeah.
One?
Oh, no.
No. On the left side, we have how many? Two. We have to condense it. Subtraction in log will make it a what? Division. Good job, sir. So 4 divided by what? X equals natural log of 36. Now do we have one log on each side?
Yeah.
Yep, drop it. Drop it like it's hot. Okay, how do we solve this? Remember, guys, LCD is what? What's LCD? X. So it means we have to multiply by X. Okay? So, left side, what do we have? 4 equals 36x. Divide both sides by 36. Sorry. All right. X is 1 over 9. Don't box it up yet. Plug it in. Would it make any of our log terms negative? No. Then box it up. All right, Chelsea, are we going too fast? No? Okay. Okay, are we going too fast?
What?
Are we going too fast?
No.
No. All right, we can move on. Do we have one log on each side? No. So, what should we do first? Yep, condense it. The bases are the same, so we can definitely condense. Oh, that is so fat. All right. I need a thinner pen. Log base 4. Addition in log makes these two what? Multiply. Okay. All right. We only have one log on the left side. Can't drop log base 4, y'all. What shall we do? Huh? No, tell me what to do. Foil. Okay, let's foil. Okay, let's foil. X times x is? X squared. X times negative 4 is? And then in the middle, negative 4x and a positive 2x will give us eventually a what? Okay, you can go straight there if you want. And then 2 times negative 4 is negative 8. Okay, we foiled it. This is where we're at. Now what? What should we do now? Corey? Correct.
How'd you write 0?
Oh, I'm sorry, 2. Sorry. Yeah, guys, we should be able to go forward and backward, okay? Because we can't drop the log base 4. And the only way to undo log is exponential. What's your base? 4. 4 to the what power? Second equals x squared minus 2x minus 8. What's 4 squared, y'all? 16 equals x squared minus 2x minus 8. Now what? Not yet. Yeah, we have to move it. So that way one of your equal sign is a 0. Okay? Okay. Move 16. Remember, factoring will only benefit us if we can use the 0 property. The 0 property said if we have A times B, y'all, equals to 0, that means either A equals to 0 or B equals to 0. But this has to equal to what? 0 for us to use it, okay? So 0 equals x squared minus 2x minus what?
24.
Is it factorable? Yeah. Good. Straight up, give me the 2 factors when you're ready. Okay, so x minus 6, x plus 4, It equals to 0, so we can take each factor and do what? Yep, equal to 0. So x minus 6 equals to 0. X plus 4 equals to 0. We currently have two x values. Okay. Can I keep both? No. Let's plug it in. Plug 6 in. Is that going to make any of our logs negative? No. Plug negative 4 in. Yes. So 6 is the only one that we can keep. Negative 4 is the extraneous answer that we can't keep. Does that make sense? What is extraneous answer? An answer that we cannot keep. Okay. We solved it. It appeared. Just can't keep it. Oh, man. Look at example 6. Does it look like we have one log on each side? Yes, but. There's a but. There's another number. So we can't just go and drop it. Okay. So what we need to do is move all the log to one side. Okay. So for us to move all of the log to one side, we will subtract it as normal. Okay, so this one is now 2 equals 2 times log base 5 of 10 minus log base 5 of x. So now the logs are one side. We have to rewrite it. Whenever we have a leading coefficient, guys, in log, how do we rewrite it? It's an exponent. So we have to rewrite this as log base 5 of what? 10 to the second minus log base 5 of x. What's 10 to the second? 100. There's also a subtraction of 2 logs. What would those be rewritten as? Subtraction in log will become what? Division, right? So okay, so 2 equals log base 5, division of 100 divided by x. Okay, now we condense it down to 1 log. We can't drop log base 5. Now what? Exponential. 5 to the what? Second equals 100 over x. 5 to the second is 25. What's your LCD? X. So multiply each and every term by x. So 25x equals 100. Divide both sides by x is 4. Plug it in first before we box. Would it make any of a log negative? No. Okay, then box it. All right, Marco, how many more examples do we have? 3. All right, let's find those 3. Jackson, can you help us read the next example?
2 log base 6 4 minus 1/3 log base 6 times 8 equals log base 6
of x, yep. All right, guys. Do we have 1 log on each side? 1 log on each side? No. So we have to condense it, okay, to make sure there's only 1 on each side. All right, the leading coefficient in the front, they become what? Exponential. So let's do that first. Log base 6 of 4 to the second power minus log base 6 of 8 to what power? 1/3. Okay. This stays as is. Okay, what's 4 squared? 16. So log base 6 of 16 minus. If we're not comfortable with a rational exponent of 1/3, we can rewrite it as what? Cube what? What root? Cube root, right? What is cube root of 8? 2. So now, guys, log base 6 of 16 minus log base 6 of 2 equals, again, our goal is to get it down to 1 log on each side. Subtraction in log will make it a what? Division. So 16 divided by 2 is what? 8. I'll write this step because Some of you can go straight here, write 8, and that's okay. If you are comfortable with that, go for it. If you're not, write this step and then write 8. Okay, you have log base 6 on each side. Can I drop it? So that means x is straight up what? Plug it in first, y'all. It works. Box it up. And
That's
whole.
a lot of work.
That's okay. I'm gonna wait for you, buddy. Don't be. I will always wait for you. Good news, Kane. I even recorded this. You can watch it over and over again. Okay, guys, X-intercept. You fill it out. X-intercept when we set what equals to what? Right, so spell that out. We set y equals to 0. So, and then Y-intercept is when we set what equals to what? All right, you spell those out on those lines because we have been spelling those out for the last how many times now, right, guys? Okay. You spell out those things. X-intercept, we set y equals to 0. Y-intercept, we set x equals to 0. Okay. All right, Carter, just 2 more, buddy. Okay, to find the y-intercept and x-intercept, we have done this plenty, okay? I'm going to divide each question into 2. One is going to be for x-intercept, and then one's for the y-intercept, okay? Just to be organized. Okay, so x-intercept, y must be 0. Y-intercept, x must be 0. So 0 equals negative log base 3 of x plus 5 plus 2. All right, tell us what to do, please. What should we do first? Subtract the 2. Excellent. After that, we do what? Divide by negative 1. Well said. Okay, so if we divide both sides by negative 1, what's negative 2 divided by negative 1? 2. So 2 equals positive log base 3 of x plus 5. Okay, we have 1 log, y'all. How do we undo a log? Exponential. 3 to the what? Second equals what? X plus 5. What's 3 squared, y'all? So 9 plus 5. Bless you. I'm sorry, 9 minus 5, not plus. 9 minus 5, because we had to subtract that over. What's 9 minus 5? 4. All right, write it as an ordered pair. 4 comma what? 0. I feel like y-intercept is usually a bit easier. Am I correct? Way easier. Less work, I believe. Okay, y-intercept is when x equals to 0. So y equals negative log base 3. 0 plus 5 is 5.
Why is that number? Why is number 8 number 9?
Why is number 8? You're right. You know what? We just can't count. I'm sorry. I apologize for all the attitude teachers. It's supposed to be, let's see. So that's supposed to be 8 and 9. Yep. So this is supposed to be 8. Sorry, Kang. You know? All right. Do you think we need a calculator here?
Yeah.
We might. Okay. So we need to put it in exact form and then decimal form, okay? We're going to keep it 3 decimal places. So the exact form would be, y is going to be, what do you want to write? What should we write in exact form? Negative. Would you guys agree that this is going to be negative log of what over what? 5 over log of 3 and then plus 2, right? So that's your exact form. Now go ahead and punch it in your calculator and then let me, hey, practice using your calculator, okay? So can you please practice punch it in? We'll have it as exact form and a non-exact form.
about 0.535.
Okay, what do you guys have? Okay, so let me double check you guys. Log base 3 of 5. Oops. Plus 2. Okay, so 0.3 decimal places. So 535. Someone confirm?
Yeah.
Perfect. Box them both up. All right, now we have the real 9. Last question of today. X-intercept means we're going to set what equals to what? 0 equals to what? What? 0 equals y. All right, 0 equals. All right, guys, we do have a leading coefficient in the front. Where does it go?
Exponent.
As an exponent. Good. Okay. So log base of a half. This is x plus 1. An exponent of what? 2. Okay. All right, step number 2. Now what?
Add 6.
Add 6. You're right. We want to have log. So if we add 6, it's now just 6 equals log base half of x plus 1 quantity squared. Now what? Exponential, yep. Anytime, guys, we only have one log, we want to rewrite it as an exponential. What's your base? 1/2. 1/2 to the what power? 6 equals. We do want to FOIL this out, okay? So let's FOIL that. I'm going to write it twice and then FOIL. Okay. 1/2 times 1/2 times 1/2, 6 of that. What would that be? 1 to the 6? No, 2 to the 6. That's what 1/2 means. Well, obviously 1 to the 6 is what? 1. What's 2 to the 6, y'all? 64. All right, so let's FOIL this out. X times x is x squared plus an x plus 1. So now that equals to x squared plus 2x plus 1. Okay, LCD. What's an LCD? 64. We do want to clear out fractions because so it's easier for you guys to work with non-fractions. So multiply each and every side by 64. So this is 1 equals 64x squared plus 64 times 2 is what? 128 plus 64. Subtract 1 from both sides? Yes or no? 128. Oh, thank you. I'm missing an x. Thank you. Okay, subtract 1 from both sides. Yes or no? All right, so what would that be? All right. 64x squared plus 128x plus 63. All right, let's check it out. What should we do now? Yeah, let's try to factor. Ooh, that is some ugly numbers, isn't it?
Yeah. Really ugly.
When it's so ugly and you can't think of the factors, you know what you can do?
That one thing.
That one thing. Which one thing?
That thing.
Yeah. Sometimes when it's such, the factor is so big and you're like, you know what? It's easier to do what? Nothing. Okay. Quadratic formula. Okay.
I just followed up.
All right. So x equals negative b. Students, b is your positive 128. So negative 128 plus or minus. I do need some calculator help. Okay, so get ready. All right, plus or minus square root b squared. So 128 squared minus 4 times a. A is 64 times c is 63 all over 2 times 64. Okay. Levi, what's 128 squared? I do need some calculator help.
168.
Hold on. All right, hold on. 16,384. Thank you. Tamer, what's negative 4 times 64 times 63?
Negative 16,128.
16,128. Like that, Tamer, check my work. Is that right?
Yeah.
Okay. 2 times 64, we kind of got that earlier. It was 128. Okay, now, Sean, punch it in. 16 under the radical. What is that going to give us? Yeah, 16,384 minus that. Oh, sorry, there's a plus and minus there. Okay, so negative 128 plus or minus 256, you said? Can you do square root of that for me? Oh, look how beautiful that is. Woo! All right, so negative 128 plus 16 divided by 128, and then x equals negative 28 minus 16 divided by 128. Okay, take your calculator, compute both. Give me both answers here, and then we have to check to see which one we can keep. Okay. Negative 128 plus 16, hit enter, divided by 128. So this came out to be a negative 7/8. Someone confirm or deny? Confirm. All right. Negative 28 minus 16, hit enter, divided by 128. Math. Okay. This came out to be a negative 9/8. Okay, before we get too happy, we got to check it. Okay. This is a negative as well. Guys, they're both negative. All right. Plug it in for me. Would it make our expression original negative? Yeah. Both of them would make a negative? The 9/8 would make a negative. The negative 7/8 plus 1, that's a positive. Would you guys agree? So we can only keep one of the two x-intercepts here. So this is an extraneous answer that we cannot keep. So one answer, negative 7/8, comma, 0. All right. Okie dokie. Last one. Y-intercept is the easiest because all we have to do is now put in 0 for x. So y equals 2 times log of a half. What's 0 plus 1? 1. Okay. So now y equals log base half of 1. I'm going to rewrite the 2 as a what? Exponent. What's 1 square, y'all? 1. Okay. So now I want you guys to do this for me. Log base a half of 1. I want you to type in your calculator so that way we can understand this. Log base half of 1. What do you think this is going to give us? Even just this alone. What would that give us? What is it?
Isn't it just 0 divided by something?
Yeah, if you type in log of 1, y'all, hit enter, what did the calculator say? 0. Students, log base anything of 1 is always 0. There's no exact form here. I mean, there's no decimal form because it's this straight up is 0. Log base anything of 1 is always 0. So this is the final answer. So guys, the takeaway is, I want you guys to, hold on. Log, whatever base it is, of 1, it's always what? 0.